Welcome, everybody. I'm delighted to introduce you to Oisin Deery, who is my colleague here at Macquarie. He's a DECRA fellow. He's been stuck for the last 2 years or so in the frozen north, but will be arriving in Sydney in September and is looking forward to going to the beach and scuba diving, I believe.
Yes, I hope to do lots of scuba diving.
Oisin, thanks so much for joining us today or this evening, I suppose it is for you. And I'm looking forward to the conversation.
Great. I should also just briefly mention that I'm technically also just on leave of absence from York. So just a little bit of a shout out to York, where I've been prior to taking up my position at Macquarie. Okay, yeah. So I guess you've got questions for me.
I do, yeah. So I've assigned your paper with Bailey for this week. And as I understand it, this paper was prepared for the Horizon Scanning series on effective and ethical development of artificial intelligence.
Yes.
What can you tell us about the scanning series and the impact that this work is having on policy?
Well, this is my first chance to exercise intellectual humility, because I actually don't know very much about what's going on with the scanning series since Catherine and I wrote that paper. So I should mention, just for whoever's watching this, that Bailey is actually Catherine Bailey, my wife, but also a co-author on this and several other papers. So I haven't followed it that closely since I've been in Canada, but as far as I understand, a central focus of the Horizon Scanning project is the issue of trust in AI systems. I think that's one of their main focuses. But I mean, one of the things I suppose I want to say here is that I think that there are some basic confusions. When I've looked at some of the papers that have been contributed to that, I think there's some basic sort of conceptual confusions related to how they're thinking about trust in AI systems that I think potentially hinder having a positive impact on policy and on other target areas. So I don't want to go too much off into left field or anything, but I think one input paper, I think I have it here, for the Horizon Scanning series that focuses on trust is Riva Liederman's paper, The Effective and Ethical Development of Artificial Intelligence, an Opportunity to Improve Our Well-Being. Now, in the paper, she writes, I have a quote here. She writes that while trust has traditionally been a concept used to describe human-to-human interactions, many previous studies have shown that it's valid to use the concept of trust to describe the way in which the relationship between humans and computers or automation is mediated. Now, I think that is quite mistaken, kind of deeply mistaken, actually. And anytime you feel like it, Mark, you can just tell me to stop and we'll go on to the next question. But I do have a few things to say on the issue of trust here in relation to AI systems.
No, I mean, that's fantastic,
That's
because
okay.
the whole course is kind of framed around the question of trust and trustworthiness.
Oh, I didn't realize that. Okay, well then it's actually appropriate.
Yeah. So earlier we had a conversation with Karen Jones about her paper on trustworthiness. So yeah, this is exactly on topic.
Okay, so I think that the reason that the quote I just read from Liederman is kind of deeply mistaken is because it doesn't distinguish properly, I think, between reliance and trust in the first place. And that leads to confusion, such as, I think, inappropriately treating AI systems like people, for example, because when you sort of apply a concept that might only really truly apply to humans, you sort of end up elevating, and this happens a lot in AI, especially as treated in the popular media, where it kind of gets elevated to a status a little bit sort of without people necessarily meaning to, but just because of this kind of conceptual slippage and confusion, I think. So, I mean, in a colloquial sense, we can rely even on a natural phenomenon like the weather. I'm relying on it being a sunny day tomorrow. Or objects, I rely on my car to get me to work or whatever. And we also rely on people. So we might have confidence that somebody's going to treat us reasonably well, and so we rely on them in that regard. Or We might have confidence that people will prove reliable under tests to their reliability, so something like that. And there are other examples, but all these are still forms of mere reliance, I think. Now, the way some people put it in the literature on trust, I remember getting into this literature a little bit in the past. Genuine trust, by contrast with just reliance like that, seems to require something like vulnerability to betrayal, if that makes sense. And it seems like we can only be betrayed by persons, properly speaking. So Pamela Hieronymi, who's written on this, of course, as well, distinguishes between what she calls less than full-fledged trust and full-fledged trust. So you might doubt somebody's trustworthiness, where this is now not even just mere reliance, but it's something like I said a moment ago, being vulnerable to betrayal by them when you entrust some good to them, let's say. So you might doubt somebody's trustworthiness, but you still decide to entrust a good to them in some way. And so you're incurring that vulnerability there. So it is trust, but it's not full-fledged trust in her view. So full-fledged trust for her is when you entrust a good to a person and you firmly believe that you won't be betrayed, right? So then you got a pretty ramped up idea of trust here, but on either of those notions, it's not clear that that sort of thing can apply to machines or AI systems. So it seems like we can only properly trust in either of the senses that Hieronymi picks out, persons. And trust in persons is different than mere reliance on them.
That's interesting. I mean, so I was talking with Karen about this exact issue. And her suggestion was that you can trust agents. So you can trust a person. You can also trust a group of people, as long as that group constitutes an agent. And it might even be possible to trust a socio-technical system if it's organized in such a way as to actually qualify as an agent. But to merely trust an artifact or a piece of software seems to be a kind of category error.
That's exactly my point. It is a sort of category error. And I think Karen Jones is exactly right about that. In fact, I pulled up a quote from her as well, where she says, trusting is not an attitude that we can adopt towards machinery, she says. She goes on, I can rely on my car to get me from A to B, but my old car is reliable rather than trustworthy. And she says, one can only trust things that have wills. And now by that, we're not going to get all into that, but she means roughly having a certain sort of motivational structure, okay? And she thinks that because she says only things that have wills can have good wills. And that's where the idea of full-fledged trust would come in, where you're relying on the goodwill of somebody in having the right sort of motivational structure or whatever. But she ends the quote by saying, machinery can be relied upon, but only agents, and I'm sort of reading that as persons can be trusted. But you're absolutely right. I heard category is a little bit broader than persons to include organizations, groups, and things like that. I just didn't want to get into all that technicality here. But whether we're talking about agents more broadly in that sense or about persons more narrowly, I think that's absolutely the right sort of that's the way to think about it and to get over that sort of category or conceptual error.
Great. Well, so you frame the paper around three main questions. The first is, are there problems associated with using models based on population averages to predict individual outcomes? And then the second is, how might these models further the marginalization of already vulnerable populations? And then the third is, what are the sources of biases in statistical models? And I guess all of these relate to trust in various ways, because if people are relying on these models or trusting the people who built them, then they end up making decisions that have sometimes pretty severe consequences on people's lives. And if I understand correctly, your answers to these questions are For the first one, yes, there are problems, and sometimes serious problems, and that the answer to the second question is that the already vulnerable are especially likely to be victimized by these models. And then the answer to the third question is researcher negligence, researcher recklessness, and the general fact that society is kind of fucked up in various ways means that these models mirror our own flaws back to us. And if we use them not just as descriptions of ourselves, but as norms for making decisions, then we're going to recapitulate the problems that already exist. Is this a fair characterization of what you're saying in the paper, or what would you add to that?
I think that's mostly, I mean, it was a very brief paper, but I think that's mostly a fair characterization. Regarding the last issue there about models mirroring society back to us, that's actually a topic that Catherine and I have been working on in detail much more in a recent paper, which is currently under review. We're hoping will be accepted. So the idea here is that, yes, you know, in some way, these models are reflecting back biases to us and various sorts of problems. So in the paper that we've been working on recently, we're looking at bias in natural language processing, and in particular sexist and racist bias, excuse me. Now, the reason that it's kind of taken by some people to be mirroring something back to us is that we're training these natural language processing models, whatever they are, on vast corpora of language that has been produced by humans. The NLP models are trained on those, and because the corpora contain biases, including sexist and racist biases and other biases, they reflect. So the outputs, the natural language processing system itself, or model itself, and its outputs will also then reflect that sort of bias. But recently, a lot of researchers have been sort of pushing back on that idea. So the claim they're making is that natural language processing systems don't always accurately mirror society back to us. So Emily Bender, Timnit Gebru, and Margaret Mitchell, among various others, have claimed that existing models in various areas of natural language processing don't accurately mirror society back to us, since the corpora that they're trained on don't, for example, reflect marginalized voices sufficiently. And so we're actually getting a picture that's not accurate, as it were. And so we're getting, it's like a mirror at the Hall of Mirrors or something. It's reflecting some sort of weird, warped picture back to us, because you're missing out on these marginalized voices who don't necessarily engage in producing the kind of texts on which these corpora are based.
That's interesting. So one fact I learned recently was that a lot of early NLP was trained on the Enron emails. So for those who are younger than us, Enron was a notorious company in the United States that engaged in massive fraud, and eventually they were caught, and their emails got entered into the public record. And one of the weird things that happens in computer science is that computer scientists don't like to curate their own data sets. They want to just pull something off the shelf. So if they are training a language model, they will not go and get a billion people to talk to them. They'll just go and grab whatever digitized text is already available. And so in this example, the Enron emails were used for training just sort of generic natural language. And of course, you might think that like the way people talk when they're communicating about doing fraud might not be representative of the way that everyone talks all the time.
I'm
And I
sure
guess
there was some code switching going on for a start.
yeah, among other things, and most of them were men, and most of them were white. So I guess the idea here is that, you know, if you're training one of these language models and your input is coming primarily from one segment of society, then you're not going to reflect society. You're going to get a mirror just of that selected portion. Is that kind of the idea?
I take it that that's the idea, and that's the idea that we take Gebru and Mitchell and the others to be sort of pushing. Yeah, I mean, we're actually trying to push back on that. We're borrowing a couple of distinctions from other researchers. I think Harini Suresh and John Guttag have a distinction they make between representational bias and historical bias. So representational bias for them results just from imperfect measuring or sampling, right? Mm-hmm. And so I would think of the kind of bias that there is in the data in its not adequately reflecting marginalized voices, let's say, to be a kind of representational bias. It's not, it's an imperfect sampling, let's say, of data, okay? What they call historical bias arises even in cases where the data is perfectly measured and sampled. So basically what they're saying is that if that data somehow actually reflects how the world is now or has been in the past, was in the past, you're going to have that's a different kind of bias where you've got this accurate sort of description, but it contains biases because people use language, let's say, in sexist and racist ways. Does that make sense?
Yeah, I guess I'm a little bit puzzled though, because it seems to presuppose that people aren't racist and sexist now, and clearly many of them.
Oh gosh, no, I didn't mean to suggest that at all. No. I mean, whether you take your sample from, I'm imagining, let's say, the kind of hypothetical case of having a language corpora that is somehow, I mean, this is impossible, of course, but somehow sampled from, it's based on all of the language ever produced by all people everywhere, including now, right? That's a great data set to have, and I don't think we will ever get those to have anything like that. But even in a case where you have that, you're not going to have what they call representational bias. You're not going to have an error in the sampling of what, because that's ruled out from the beginning. It's a perfectly the sampling is perfect, right? So the idea there is that you have bias, but it's a different kind of bias. It is the bias that is so it's produced in the language that people have produced and produce now, and that language, including language that's produced now, contains sexist, let's say, and racist bias. And then because of the accuracy of the model in being maximally accurate in the hypothetical case we're considering, in fact, in order to be accurate, it must reflect the biases that have been expressed by us.
Yeah, okay, yeah. So if I understand correctly, the idea is that there's a kind of ambiguity to this word bias. So yes, it can be used in a purely descriptive way just to refer to essentially correlation. Yeah. And it can also refer to something like unjust prejudice.
Yes.
Yeah.
And what we're sort of we're claiming something even more contentious, I suppose, in our recent work. So we're claiming that there can sometimes be a value to retaining. So what we've got there in this kind of hypothetical case and the biases that are reflected is that we do now have a mirror of a fucked up society, as you put it. And so we argue actually that sometimes there can be a value to retaining this fucked up picture. I'm not sure how much I'm allowed to swear here, but in any case,
it's
everything out of my system there. So we think there can be a value to that. I mean, I can go on about that a little bit if you like, but we think there's a value to retaining that kind of picture. It can be useful for certain kinds of purposes, including it can have ethical value, we think, and it leads to a kind of a dilemma. But that might be a little bit too off topic for now. I'm not sure.
Yeah, well, if we have time, we'll return to that. It's
Yeah,
certainly
sure.
something that interests me. But I did want to ask you a few other questions. So one is, can you explain a little bit what the difference between supervised learning and other kinds of AI is? Other things like rule-based models or unsupervised learning. And I realize this is kind of a technical question, which might be a bit out of left field for the philosophy audience of this class, but
Yeah,
many of the examples in your paper involve supervised learning.
yeah.
And I'm curious whether you think this is an especially dangerous or ethically fraught kind of statistical model to use when dealing with human populations.
Right. I mean, I don't think there's anything particularly pernicious in this regard about supervised learning vis-a-vis unsupervised learning. Um, but I mean, I'm not sure if I mean, do you want me to say? I'm not sure. Do you want me to say something about what like supervised and unsupervised learning are, or is that something that?
I mean, so like the example of the melanoma classifier, that's supervised learning, right?
Yes, yeah. So
So
I mean, the basic distinction is that in supervised learning you have labeled data. Okay, um, so you're going to have one task that it's used for is what you just mentioned, which is a classification problem. Um, and that can be in the skin cancer case that we talk about in the paper. It can also be for many other purposes, like classifying email as spam or not, or recognizing whether there's a dog in a picture, and so on. So basically what you've got is you're trying to decide what class some kind of item belongs to. And the output variable is categorical. It's just sort of, it belongs to that category or not, okay? And you can have like binary classification where that's the case with the email. You're classifying an email as spam or not, right? It's just kind of two options. You can have multi-class classification where you're trying to decide whether each piece of data belongs to some n number of classes. So if you're training a system to visually recognize handwritten digits, for example, then each image of a handwritten digit is going to belong to one of 10 classes, so 0 through 9. And so what you're doing there is I mean, you can use various mathematical techniques for doing this. But the basic thing is you've got labeled data. You know what the answers are ahead of time, right? You know which digits are which, and they're labeled for the system to identify. So you've got pieces of data that are already classified, and you train your model on those. And what the model is supposed to do is try to predict which digit, let's say it is in the handwritten digits case. And then as it makes mistakes, it's got ways of iteratively correcting for its errors, and it's trying to minimize the errors that it makes until eventually it's minimizing them sufficiently that it's able to reliably classify those digits accordingly and correctly. And you've got other kinds of supervised learning, of course, like regression models and so on. But the idea, in contrast to unsupervised learning, is that you don't have labeled data in unsupervised learning. So here, there may not be any sort of particular outcome that you're interested in. You've got a lot of data, some big massive data, let's say, and you want to find patterns in that data for some purpose. And a lot of people think when I see things in the popular media all the time where, you know, unsupervised learning, people start talking about it like, oh my gosh, this is where things are off to the races, you know, and it's learning by itself and it has no supervision from human beings. It's going to take over the world or something. But there's nothing magic really going on there at all. In fact, to get an idea of how kind of magical in a way unsupervised learning is, you can do it without the machine at all, right? I mean, if you were diligent enough to do it all with pen and a paper and a calculator or something, you could do it all together by yourself. So if you're doing clustering analysis, let's say, you're trying to find whether there's clusters in your data whether things cluster in a certain way. Now, you might have suspicions about what the clusterings might be. So maybe users of a certain website have certain kinds of behavior versus other users of the website having different behaviors. And the model, using something like k-means clustering or something, will divide the data up into distinct categories where it's tracking features that are not readily available to us, and telling us that there are interesting features that these pieces of data have together versus these pieces of data. And you can arrive at all that without a machine just doing complicated statistical analysis. The machine, of course, as we all know, being involved just makes it much faster. Many more features and relationships between variables can be taken into account, and you get much more interesting and quick results. But there's nothing sort of mysterious. It's not like it's we had supervised students where we looked over their shoulder, and then we sort of took the whatever off, the gloves are off, and off they went, and they were unsupervised from now on. We're still very much sort of guiding the thing. We're giving it. We're hypothesizing clusters normally at the beginning when we're setting the thing up. And it's not mysterious in that way. But the main distinction is just that supervised uses labeled data and unsupervised doesn't.
Yeah. So I guess the thing that worries me about supervised learning is like, where do those labels come from? Right.
Yes.
It's like, you can pretend that it's all algorithms and math all the way down, but in the end, the labels come from people. Almost always.
Labeled in the supervised learning, yes. So this is one way. I see where you're going, I think. Yeah, go on.
Well, yeah. So then the question is like, well, who are those people?
Yeah.
Are they objective? Are they moral? Are they saints? Or are they, just flawed individuals like all of us? Or are they, genuine assholes? And depending on what task you're trying to accomplish, you might actually want data from assholes, right?
Yeah.
But like, the idea that there's this gold standard or ground truth, which is the labels,
yes, that's the way
is, I think, quite dangerous.
Yeah. I mean, it's not dangerous or pernicious when it's recognizing handwritten digits, or whether there's a dog in a photograph or something like that. But yes, in other cases, it's you're right, because this is what the computer scientists and data scientists call this, that the labels are the ground truth of the model, and where those labels come from in some cases obviously can be worrisome.
Yeah. Well, I guess that brings me to the next question I wanted to ask you. So I kind of gestured at this already, I guess. One of the issues that I've encountered when I was teaching ethics to computer scientists back in the Netherlands is that they really don't want to have to create and curate their own training data sets. They want to just grab something off the shelf. So I mentioned the Enron data set, for instance. And this seems dangerous to me, and also just like scientifically not good practice. So like, if you conduct a randomized controlled trial, like they do in medicine when they're doing it well, at least, you first figure out what data you need to answer your question, and then you go and collect it and analyze it. But it seems to me that in many cases in data science and AI and machine learning, the order is kind of reversed. People sort of look around for a big free data set, and then they try to figure out what questions they could sort of maybe half answer using that. And then they train up models. And this inevitably means that they use data that doesn't quite answer their question. And there are problems with what you call in the paper proxy variables, and criticize. So I wonder, like, why do you think there is this resistance to creating and curating good data sets, and what can be done about it?
Gosh, I mean, I actually have no idea why that resistance is there, and I don't really have anything wonderful to say about what to do about it. I mean, it's certainly true that there's a laziness at the very least in I sometimes I see it as a sort of giddiness at having come up with some new kind of algorithm that they want to use to develop a model for some purpose, and then it's just like, well, I want to use my tool. And you just run out into the playground and pick whatever kind of material that you can go to work with on your tool without any adjudication of whether the material is going to be is going to have problems in various
It's like a
ways.
Maslow's hammer kind of thing. Like everything is a
Yes,
nail when you only have a hammer.
yeah, something like that. But if that sort of resistance is there, then by all means, something really does need to be done about it. I mean, I don't really. Do you have any ideas?
I mean, mandatory collaboration with social scientists and ethicists,
Yeah.
something like that.
I know. I mean, that's the obvious sort of thing that crop or comes into my mind too, and some sort of policing of that kind of behavior. But the problem, I think, with setting things up in that sort of way is that you're setting things up antagonistically from the get-go, and it's always just going to be,
right.
cops and robbers, and they're trying to escape from you, and you're trying to catch them. I mean, this happens in the law where big companies hire lawyers just to protect them from
Yeah,
doing.
no, that's a good point. I mean, I guess I'm thinking of it more like, if you really want to do good science, then you need to pay for the collaborators that you need.
Yeah. No, that's right. I think some way of really encouraging as kind of something that's positively motivated. So the carrot rather than the stick here, you get people to genuinely begin to care a little bit more about collaboration is key. And I think on the side of social scientists and philosophers who want to engage with scientists on these matters, and computer scientists, I think we have to be careful not to be gentle in how we come at it. It's easy for philosophers, especially. I can speak about them mostly because I am a philosopher. It's easy for us to sort of wade in and say, "You guys, you're all idiotic and you don't know what you're doing. You're a bunch of conceptual confusions." But of course, people get their backs up against the wall immediately, and understandably when you come in like that. So I think both sides have to find ways of moving towards each other.
Yeah, fair enough.
Yeah.
Well, so the next thing I wanted to bring up is this point that you make about whether a model can learn from feedback. And this kind of connects to one of the themes in the class, namely trust and trustworthiness, as I mentioned earlier. Jason DeCruz, I'm not sure if you're familiar with him. He's an American philosopher in New York, I believe. He and several others have pointed out that there's a kind of asymmetry between trust and distrust. So like if I put my trust in you, then I'm likely to get feedback about whether I made the right call. Either you live up to my expectations or you don't. So if you do live up to my expectations, then I'm like, okay, I made the right call. If you don't, maybe I'm upset with you, but I also learned something about the world and about my own ability to place my trust. Whereas like if I don't trust you, if I outright distrust you, then I'm rarely in a position to learn whether you would have proven trustworthy if I had actually placed my trust in you. And several of the examples that you use in the paper seem to trade on this asymmetry. So like there's the case of offering someone a loan. If the bank doesn't give someone the money, then they don't find out, or they're very unlikely to find out whether it would have been repaid. By contrast, if they actually do give someone a loan, then they get feedback because they either get the money or they don't. So this seems to connect to your point about vulnerable populations. Like they're likely to be distrusted by statistical models, either because of historical biases or just because there's not enough data about them to make a call. Um, and then that distrust is liable to be kind of self-sealing because it's not prone to correction. Do you have any thoughts about how to address that kind of problem?
Well, my main thought is that it is a serious problem and a very pernicious one. I mean, you're quite right that it exacerbates marginalization of certain groups just because they never get the opportunity to for a system or for a group of people, if it came down to it, to find out whether they would be trustworthy once trust were placed in them. But I mean, in relation to the loan example, and there are lots of other examples like this. I mean, the same problem arises much more widely. So I think models can't be, these sorts of models can't really be used to adjudicate hiring and firing, for example, by say looking at CVs or the past performances of employees. Because they're just not, I don't think these sorts of models are capable of doing a good job in this sort of thing. At bottom, I think that's just a stupid way to do things. I don't think these sorts of tasks are the tasks that we should be deploying algorithms to try to adjudicate and decide. So it might be just that models of this sort shouldn't be used in that sort of way. Shouldn't be used to adjudicate whether somebody gets a loan because of these problems.
So the solution is not to build a better model, but just not to use it in the first place.
I'm not convinced. I'm always open to somebody showing me something, but I'm not convinced that there is a better way of doing it. It just doesn't seem like the sort of problem that is best suited to this sort of solution.
Yeah.
Now, if somebody comes along eventually and says, I just think the effort, put it this way, I think the effort of computer scientists developing all these kinds of things would be better placed elsewhere. You can get more bang for your buck, as it were, doing lots of very interesting and useful things with algorithms and with machine learning. I don't think that this is one of the obvious kind of low-hanging fruit areas, right? I think it's a bit of a stretch. I think we've seen a lot of problems with it already. If somebody wants to work on it and try to come up with something better and eventually does, then hats off, and we'll test that out and see if it's worthy of being adopted. But for the moment, I just don't think that's the right sort of problem for this sort of solution.
Yeah. Yeah, I mean, I think hiring and firing is a really fraught kind of example. Like I read this audit a few years ago about one of these hiring algorithms. It had been trained on historical data. So it was basically trying to pick out the sort of CV or resume that was associated with the sort of person who in the past at this company had been hired or promoted. And then this question of like, where's the training data coming from? Comes up immediately, right? Because if you have been making hiring and promotion decisions in a biased or prejudiced way, then the algorithm is just going to replicate that. And
there's no scope for learning from feedback at all.
And what this audit found was that the two strongest predictors for whether someone would be sort of hired or promoted were whether the person was named Jared and whether they had played lacrosse in high school.
That's doesn't sound terribly useful. No.
Yeah, I mean, so I'm not sure if this is even a question, but it seems like this is a case where if you think about how these models actually work, it becomes obvious immediately why you wouldn't want to use supervised learning in this sort of way for this sort of task. If you wanted to like figure out, what were the prejudices of managers at this company over the last 5 decades, then you could actually use essentially the same model. But if you are actually going to be making decisions about who to hire or who to promote, this just seems to me to be crazy.
Yeah, I agree totally. I mean, the being clear about the task that one is trying to achieve with a certain model is absolutely critical. And as you pointed out there, I mean, this sort of model could be used for a much better purpose to examine, sexist hiring practices or other problematic hiring practices over time. But for hiring and firing, it's not. I mean, I just think that, as I said in response to the previous question, this sort of deployment of statistical models, I just think is stupid. I mean, interestingly, Catherine and I talk in some of our papers. I can't remember whether it was in that paper about certain kinds of problems that seem like they're fairly easily avoidable. I mean, we talk about the dermatology case in that sense. So it's like the answer was just like use better data. Okay, I mean, get your head screwed on, and you've forgotten about half the world in the training data. So those things are fairly easily avoidable. I mean, there are technical problems maybe, but it's easy to see how to resolve the issue. And then others are more difficult to avoid, and some are, in some sense, kind of, in principle, perhaps impossible to avoid. I won't talk about those now, but I mean, I think here that the bias in these sorts of models you're talking about for hiring and firing is utterly avoidable. Don't use those kinds of models for those kinds of purposes, right? I mean, it's avoidable in that simplistic sense. But if we insist on doing that kind of stuff and using algorithms for those kinds of purposes, then I think the case is one of a difficult to avoid problem at the very least. But like I said before, I just don't think that difficulty is something that it's in our, that should be at the top of our list of things to tackle. I think there's so much that can be done with good machine learning and with good statistical models. And here, I think this was just the wrong sort of thing to do in the first place.
Right, I see. I mean, so the dermatology example is also quite confronting. If I understand correctly, you and Catherine actually just went and looked at all of these images that were used in the training of this model. I mean, it seems almost tailor-made to illustrate how already vulnerable populations can be harmed by statistical models. Like rich white folks get individualized attention from human diagnosticians, and everyone else gets an app. So in a way, this seems like not a problem for computer scientists, but a problem of like political economy. It's a question of, whose priorities and needs are taken seriously by the system, rather than like something that has to do with how algorithms work. Do you think that that's maybe the area where more pushback needs to occur, that instead of pretending that things are solvable with software, we just say like, no, actually society is messed up in various ways and we need to ensure that vulnerable populations are looked after?
Yeah. I mean, there's a few things to say in response to that. I think, first of all, as I mentioned a moment ago, I think this was a case of an easy fix. You just use better data. The model itself seemed to be quite good and accurate, but it was just trained appallingly. And the way in which it was trained, it was an astonishing oversight. I mean, as you said, it was almost tailor-made to show a problem here. But it was just an astonishing oversight for these people to get so giddy about this thing that some of them were thinking that, we wouldn't need human diagnoses anymore at all, and they could just devote their time to research or something, and we would just hand it all over to these systems.
But it's not just an oversight by the people who made that algorithm and published it.
No, that's right.
The people who responded, the press release around it, like everybody.
Right. Everybody just seems to, I mean, it's kind of like when, at the beginning of the Ukraine war, people started saying things like, there's all these refugees coming out of Ukraine. And when kind of pressed on why they didn't feel so aghast and similarly about other refugees coming from elsewhere in the world, many of them actually just sort of didn't know. And then others began to see why they had done that. And they just said, well, it's because they're white, You can have this background bias that people can have where it filters information in a certain way. You're right. The journalists and everybody reporting on that, they weren't seeing the problem either. You know, it was just something that everybody was missing. And I think it's really important to talk about your kind of political economy issue. I think it's important to take cases like that and for all of us to be on the lookout for cases like that, and then to really push the other way on them and say, if anything, we shouldn't be getting giddy about some new tool we have for diagnosing skin cancer. What we've done here, additionally, and maybe more fundamentally, is like shone a spotlight on some deep problems in, let's say, our society, the US in that case, and in the priorities of those putting together the model, in the way in which the data was gathered. It wasn't even always the fault of the people putting together the thing, because, as I think we mentioned in one of the papers, a lot of this is some of the least well-funded clinics where people will go to get tested for skin cancer don't have the availability of photographing the lesions, and so then that's just excluded from being part of the data set in any case. Whereas the wealthier, better funded clinics will have that equipment. So it highlights and puts a spotlight on all of these issues that suddenly pop up if you start looking at them. And I think this sort of case should be used to really turn around and look at those issues much better.
Yeah, so I mean, one thing that you could do is have what Mitchell and Gabru call these model cards, where you say, okay, we've got this classifier, it only works on white skin. That's all we're going to claim. And in a sense, that's fine, right? But then you might go further and ask, like, well, why are we making models that only work for white skin? And
yes, yeah.
You call this an easy to solve problem, and I guess technically,
I guess in principle, I mean, it's easy, but to get the better data set requires fixing so many things throughout the society that in order to get that data, you would have actually improved society quite substantially.
Yeah, that's kind of the concern I have. I mean, that the point that I want to make, which is that in principle, technically, it's not that difficult to get better data, but the social and political conditions for the possibility of collecting that data would be a much changed world.
Yeah, that's right.
This sort of points to the sort of, I guess, ethical presuppositions that are in play when people are doing what seems like just math and software.
Yeah, I agree.
Great. Well, on that bleak note, I need to go have another meeting. But thank you so much for your time, Oisin. And I'm really looking forward to seeing you in person.
Yes, me too.
Bye-bye.
Bye.